Welcome students. Now in this video we will start with the gate questions which are asked for the 2 marks in the topic metal cutting. Okay. So we are going to discuss the gate questions. So question number 1, let us take. A cutting tool has a nose radius of 1.8 millimeter and the feed rate for the theoretical surface roughness of 5 micron is. See, the nose radius R is given as 1.8 millimeter. They are asking the feed rate in mm per revolution. The theoretical surface roughness value is given as 5 micron, which is equal to 0.005 millimeter. We know that this RT is equal to F square upon 8R. We have seen this relation. So this 0.005 into 8 into radius 1.8 is equal to F square. So F is how much? Calculate. Very simple. That is 0.005 into 8 into 1.8. The root of the answer, it is 0.267 in millimeter per revolution. So this is correct answer. So 0.267. Very simple. Go for the next question. In orthogonal machining operation, the chip thickness and the uncut chip thickness are equal to 0.45. Okay. If the tool rake angle is 0 degree, the shear plane angle is. Okay. So here R is equal to what? Both the chip thickness and the uncut chip thickness and the chip thickness are same. That is T1 is equal to 0.45. T2 is equal to 0.45 mm. And rake angle is 0. Then they are asking what is the shear plane angle. Shear plane angle. So what is shear plane angle? Phi is equal to what? Tan inverse of this R cos alpha divided by 1 minus R sin alpha. If rake angle is 0, then phi is equal to tan inverse of R. And R is what? The ratio of T1 by T2 is 1. Okay. So tan inverse of 1, how much? Calculate. It is 45 degree. It is 45 degree. So phi is equal to 45 degree. Options are 45, 30, 18 and 60. So correct answer is 45 degree. Next question. During the orthogonal cutting of mild steel with a 10 degree rake angle, chip thickness ratio was obtained as 0.4. The shear angle, calculate from the data. Very simple thing again. So here the chip thickness ratio R is given as 0.4. The rake angle alpha is given as 10 degree. Isn't it? And they are asking the shear angle phi. Very easy. This is the formula only. So what is phi? Tan inverse of 0.4 cos of 10 divided by 1 minus 0.4 sin of 10. So calculate. So this will be 0.4 sin 10, 1 minus answer cos 10 divided by shift tan inverse of answer. It is 21.84. 21.84 degrees. Okay, very easy. Let us take next question. Two tools P and Q have signature. So tool signature given, tool P, this is tool P and tool Q. The tool signatures are given. So for P it is 5 degree, 5 degree, 6 degree, 6 degree, 8 degree, 30 degree and 0. And this is 5 degree, 5 degree, 7 degree, 7 degree, 8 degree, 15 degree and 0. Okay. So both are ASA, American Standard Association tool signature system. They are used to turn the component under the same machining conditions. Okay. If HP and HQ, if HP and HQ are what? Are denote the peak to valley heights of the surface produced by the tools P and Q, then this ratio HP as to HQ is equal to how much? Okay, and C options are option A, this is tan 8 plus cot 15 degree divided by tan 8 degree plus cot 30 degree. Option B, tan of 15 degree plus cot of 8 degree divided by tan of 30 degree plus cot of 8 degree. Option C, tan of 15 degree plus cot of 7 degree divided by tan of 30 degree plus cot of 7 degree. And option D, tan of 7 degree plus cot of 15 degree divided by tan of 7 degree plus cot of 30 degree. So see, this is the data. The tool signature is given for tool P and Q, and maximum peak to valley distance ratio for P as to Q, that is HP as to HQ they are asking, and the cutting conditions are same. Okay, so here, so as per this ASA, what is this tool signature? So this is the back rake angle, this is side rake angle, then theta E, theta S, CE and CS and nose radius are, we know this very well. So we know that when the end cutting edge and side cutting edge angles are known to us, and definitely they are affecting the produced surface finish on the component. So here we know that this H is equal to what? F divided by tan CS plus cot C. We have seen this relation, how it comes. Okay, and say if I write it this for HP and HQ, it will be say F divided by tan CS plus cot C. The cutting condition same means the feed is same. Take this ratio, what will get? This HP divided by HQ. So it is nothing but this will go in the numerator, tan CS plus cot CE for Q divided by tan CE, tan CS plus cot CE for P. So tell me, for Q what is CS? For Q, CS is what? This 15 degree and CE is 8 degree. So tan of 15 plus cot of 8, these are degrees, divided by, for tool P, CS is 30 and CE is 8. So tan of 30 degree plus cot of 8 degree. So this is the correct answer. So what is the answer? Tan of 15 degree plus cot of 8 degree divided by tan of 30 degree plus cot of 8 degree. So B, Bombay is the correct answer. Please see this. Next question. In an orthogonal cutting operation, I will write the data. In an orthogonal cutting operation, the uncut chip thickness T1 is given as 0.5, cutting speed is given as 20 meter per minute, width of cut is given as 5 mm and chip thickness is given as 0.7 mm. The thrust force Ft is given as 200 Newton and cutting force Fc is given as 1200 Newton. Assume merchant's theory. What they are saying? Assume merchant's theory. The value of shear angle and the shear strain. Question number 1. The value of shear angle and shear strain, that is gamma. And second, the coefficient of friction at the tool chip interface, mu is how much, and these values how much. Okay, so this is the question. So thrust force is given, cutting force is given. They are saying use the merchant's theory and calculate this shear angle phi, shear strain gamma, and also the coefficient of friction. So let us calculate. See, we know that tan phi is equal to what? R cos alpha divided by 1 minus R sin alpha. Alpha here how much? Take alpha here 15 degree. Okay, and solve the question. So what you get here? This R will be what? T1 divided by T2. So T1 is how much? 0.5 divided by T2, 0.7. We'll get how much? 0.5 divided by 0.7. It is 0.71. Then tan phi, you can calculate as phi is equal to tan inverse of R 0.7 cos of 15 divided by 1 minus 0.71 sine of 15. So if you calculate how much? So sine of 15, 1 minus answer 0.71 divided by answer, it is 40 degree. So phi is how much? 40 degree. Okay. And shear strain, how to calculate shear strain? We know the formula, gamma is equal to cot phi plus tan of phi minus alpha, isn't it? So what is phi? 40, the cot of 40 plus tan of 40 minus 15, that is 25. So here 1 divided by tan of 40 plus tan of 25. So it is 1.65. Gamma is how much? 1.65. This will be the shear strain in the machining. And this first question is completed. So you get phi here as 40 degree and gamma is 1.65. Now to calculate this coefficient of friction by the merchant's theory, we know that this tan of beta is equal to coefficient of friction mu is equal to Fc tan alpha plus Ft divided by Fc minus Ft tan alpha, isn't it? Or we can have this tan of beta minus alpha is equal to Ft divided by Fc. Okay, put here the value of alpha. We know the cutting force is how much? Cutting force 1200 Newton, 1200 tan of alpha 15 plus thrust force 200 divided by Fc 1200 minus 200 of tan 15. So let us solve this. So 1200 tan 15 plus 200 divided by 1200 minus 200 and tan. So it is 0.45. So it is 0.45. So this is the value of mu is equal to 0.45. Check it whether it is correct or not. So it is 0.45. Yes, it is correct. So we got this value of phi, gamma and mu here in this question.